Hello, my name is Wallace Ellis, and I'm a senior chemist at TDA Research. Today I'm going to present work on a Phase 2 SBIR project that's been funded by the U.S. Marine Corps. The name of the presentation is Automated Maintenance of Sealed Firearm Suppressors. I will discuss the project in more detail in a few slides. This slide shows some background on TDA Research. TDA has a great deal of experience in developing chemical and engineering technology for military and civilian applications. Recent technical successes include the development of desulfurization sorbents used to remove odorants from natural gas streams. This technology has been spun off as sulfatrap. TDA has also developed carbon monoxide oxidation catalysts that are used in the OBOG systems on all FA-18s. Finally, TDA has developed the only decontaminating detergent approved by the Air Force to clean aircraft. This product is known as SSDX-12. SSDX-12 is also an all-purpose detergent and is used to routinely clean aircraft. This project was run by me as well as Dr. Brian France. I have a PhD in inorganic chemistry and I have a great deal of experience with transition metal chemistry. This relates to the current project because the fouling found in firearm suppressors contains both lead and copper. Dr. Brian France led the SSDX-12 development, and he has experience in developing cleaning methods as well as in commercialization. TDA has experienced engineers and all the equipment needed to fabricate and assemble parts on this and other projects. The Marine Corps has made the decision to use suppressors on all its small arms, including automatic rifles such as the M27. The objective of this project was to develop a method to remove carbon and metal fouling from sealed suppressors with either quick detach or threaded attachments. Effective cleaning will extend the service life of the suppressor, improve its performance, and eliminate premature replacement. The expected transition target are Marine Corps intermediate maintenance activities. We also have a pending sale to the U.S. Army. We're beginning to evaluate suppressed fire on small arms. The expectations for our technology are that it will allow a suppressor to last as long as a rifle barrel, if not longer. Our goal is to be able to manufacture and deliver 1 to 2 dozen other cleaners in about 6 months. Before we started this project, there was no established method to clean a sealed suppressor, and certainly not in mass quantities. The Marine Corps needed a sustainable cleaning method that avoided solvents and caustic or corrosive chemicals. They also needed a process that did not generate large amounts of hazardous waste. Our method avoids this problem because we do not dissolve the copper or lead that is present in the fouling. Any other Defense Department or agency that uses suppressors and wants to maintain them instead of just replace them has the same needs. This slide shows our cleaner. We use an ultrasonic probe to clean the interior of a suppressor only. The suppressors can be loaded into a queue and cleaned one at a time. The model shown will clean 6 at a time. They can be different models of suppressors, although it is likely that only one type will be cleaned at a time. The suppressor is first filled with a detergent solution from below, and then the ultrasonic horn is lowered into the suppressor down to just above the first baffle. The suppressor is treated with ultrasound for about 5 minutes, while recirculating water removes loosened fouling, which is collected in a reservoir. The treatment does an excellent job cleaning the surfaces around the connection area that are adjacent to the quick connect or threads. This is important because it prevents suppressors from becoming stuck to the rifle. Poor connections can also lead to baffle strikes and reduced accuracy. The amount of material removed from the suppressor depends on the rate of fire. Suppressors on low rate of fire rifles like sniper rifles remain relatively cool during use, and the fouling has a high percentage of carbon. This fouling is brittle and relatively easy to remove with our system. Suppressors on automatic rifles can easily get red hot. The copper that collects melts and becomes extremely difficult to remove. Our cleaner displaces carbon, but the copper generally remains. The connection area is still cleaned effectively on these suppressors. We have actually finished and delivered the final version of our suppressor cleaner since this talk was approved. The base unit cleans 1 suppressor at a time. The carousel attachment allows the user to clean 6 unattended. The process is fully automated and initiated with simple commands on a touchscreen. Because it is critical to dry the suppressors after cleaning them, we also designed and built a small dryer. The final version is shown on the right. It will dry most suppressors in 10 minutes or less, even the 14-inch long suppressor used on the M110 rifle. The advantage of regularly using our cleaning system is that it will reduce the accumulation of fouling in suppressors. It will also lower the risk of baffle strikes and make it easier to remove a suppressor after use from the rifle barrel. Our process does not use any chemicals or solvents. A mild detergent and water is used for cleaning. We typically use Dawn Ultra. Regular cleaning will extend the lifetime of a suppressor and maintain its performance. Since this presentation was written, we've delivered our final multi-suppressor cleaner to Quantico, where it will soon undergo evaluation. Our primary advocate is Markhor's system at Quantico. Further development may be needed to address high-volume cleaning and drying. Our primary market is the U.S. military, and the Marine Corps will be the initial customer. We expect 10 to 20 sales during the first year. Our secondary market is the United States Army, and sales volume will be dependent on their suppressor acquisition schedule. We may also find customers in law enforcement as suppressed fire becomes more common and desirable. Our technology will solve the coming need to maintain a fleet of suppressors across the armed services. We need an order from the program office to supply intermediate maintenance activities. We've developed a concept for a high throughput appliance that will clean and dry 100 plus suppressors at a time. This will require further development and funding. Our technology will save money versus replacement costs for unmaintained suppressors that have to be decommissioned early due to damage or loss of performance caused by fouling. We are TDA Research. Our contact information is shown. TDA is located in Wheat Ridge, Colorado, and we specialize in low-impact cleaning solutions for today and tomorrow.